today. Same Common Core, geometry, G for geometry, CO for congruence, and this is number 10, which is proving theorems about triangles. Okay. Today we're going to construct the orthocenter. And of course the orthocenter we want to put down, the orthocenter comes from the altitudes. And the altitude is just simply a line segment from your angle perpendicular straight down to the opposite side, okay? What you got for me? ASB passes? Okay, thank you. So, perpendicular, we could eyeball it, right? We could eyeball it, or we can make sure we're doing a good job, so we can use our protractor and say, okay, all right, 90 degrees. So I'm trying to match up the 90. So I'm trying to match up the 90 right here, the 90 with my angle. So I've got it like trying to match it up so I get nice 90. And then I can make a little mark down here. See what I'm doing? So I'm trying to get 90 degrees matched up. Everybody see how I do that? There's my 90. Match up with my angle, right? Make a little mark down there. And then I'm just going to draw in my line. There's my altitude. And because it is at 90, I'm going to put the little box in. It is 90, right? So let's put the little box in, okay? I need to do all three altitudes, so what I do, I just turn my paper, right? I turn my paper so that I've got, you know, I've got AB flat, makes it easier for me, and I got C up there, so then I can do the same thing. I can match up my 90 there with my angle C. Maybe it looks like right about there, doesn't it? I got about 90. See, I got that? So I get my 90 degrees matched up with angle C. Looks pretty good. Make my little dot right there. Everybody good? If you're not, please ask me, okay? If you're confused, I'm going to come show you, okay? All right?
Is this
Okay. I'll come around. That's really good.
Nailed it.
It's all pretty good.
And just try to get 90 degrees with this thing. When you make a marking.
Right, have you getting it? Okay. So I'm going to make my little mark here at 90, and I'm going to draw in my other altitude. Okay. And then the last one I'm going to do, I turn it like this, right? Okay, and I want to do this side. So again, I'm going to use my protractor to try and get 90. And of course, it should go through that point, right? It should. If I did a decent job, just going to draw it through, and I know it's going to go through there. Okay. There we go. Okay. So, point P, that's my orthocenter, okay? So, properties, okay? Properties. So what happens is, the only thing the orthocenter will give us is this. So if you have 3 points, so here's what it does. If you have 3 points, and oftentimes we use it with graphing, if you have 3 points anywhere on a graph, you can find the center of that circle. You can then draw a circle that will contain all 3 points. Okay. Now the center, we have to adjust the center. Let me adjust my center. Oh, I'm going to have to bring it in a little bit. Yeah, this center is hard to find, so I'm just adjusting it. Okay. Right. Now I had to find my center, and there's a way to find our center later, okay? Alright, now, you ready to turn the page?
Wait, Paul.
I'll wait for you.
I have to finish writing that down.
Okay.
Like, what's the point in getting the orthocenter then if you find another center anyway?
Yeah, it's a little bit different because you approach the problem differently. So, and we're going to see it on graphing more than anything. So, if you end up having 3 points, right, and you want to put a circle around the 3 points, this is going to help us, okay?
Okay.
Okay, guys, when you're ready, it's more for graphing, Claire.
Oh, okay.
Okay, ready? So let's go back. Okay, now. So let's go ahead and draw a triangle JFK, -4, 1, 2, 3, 4, and 2. There's J, -2, 1, 2, 3, 4, 5, 6. There's K, and 2, 2. All right. Let's draw our triangle in. And I'll go slowly on this one, okay? And I'll zoom it in if I could, okay? Should have made a bigger graph. Okay, tell me when you're ready. Give me thumbs up. Okay? I see 1 thumbs up, 2 thumbs up. Okay? Everybody else? I'm waiting. I don't mind waiting till you get the triangle, okay? I want everybody to see how this works, okay? So, if I want perpendicular lines, right? Yeah? Did I make a mistake?
Oh, there we go.
There's a misspelling? That happens all the time.
Triangle JFK, and then there's
JKL.
JKL.
Oh my goodness. JKF, huh? JKF. Thanks. And then JKL. Either way, huh? Thanks. Found a mistake. I appreciate that. Yeah. I do make mistakes. It's kind of a bummer. Yeah. Okay. Okay, we're going to draw altitudes. Did I really? Yeah. Oh my goodness. Well, let's just call this L. Let's call this triangle JKL, JKL, JK. I'm going to call that L again. How's that? Then it's going to work, right? I got to fix this for next year, don't I? Yeah. So if it's an altitude, we know that it has to be perpendicular, right? Perpendicular. Now the first one's really easy. I mean, perpendicular, the first one's just straight down from K. This one's super easy. You guys see how that is? I mean, if it's just like straight on down, right? There's my altitude, okay? Everybody see that one? That one's easy. Just straight down from K, 90. I mean, you can see that. And obviously, it's not a bisector. It doesn't cut in half. But that one's super easy, okay? Now, the other ones are kind of hard to do. But what we know, I'm going to take this a step further. Perpendicular lines have opposite slopes, okay? So if it has opposite slopes, then if I take a look at KL, let's call it KL, right? It's down 1 over 1, down 1 over 1, down 1 over 1, down 1 over, okay? So then from J, we got to get to KL, but we got to do the opposite slope. So from J, instead of going down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, we do just the opposite, right? So we'd go up 1 over 1, up 1 over 1, up 1 over 1. And that makes it be perpendicular. It has to be perpendicular because the slopes are opposite. Okay, want me to do that again? So you ready? From KL, the slope is down 1 over 1, down 1 over 1, down 1 over. So the slope of this line is negative 1 over 1, right? So from J, we got to draw a line from J over to it, but it's got to be the opposite. So instead of going down 1 over 1, down 1 over 1, Jaden, we're going to go up 1 over 1, up 1 over, because that makes it an opposite slope. So one slope of KL, its slope is down 1 over 1. But then the slope from J, and we can call this whatever, from J, its slope is going to be 1 over 1, which is the opposite slope, right? 1 over 1, negative 1 over 1. Now look at this one. So if we're going to go from L to KJ, KJ slope is up 2 over 1, up 2 over 1, right? So KJ, its slope is up 2 over 1. So then from L to get to KJ, we're going to do just the opposite, right? So we're going to go down 1 over 2, down 1 over 2. We're going the wrong direction, right? I mean, down 1 over 2, down 1 over 2, but we're going the wrong direction. So we're just going to go the opposite way. Up 1, back 2, up 1, back 2. And sure enough, they do intersect in a single point, right? Okay, and so the coordinate of that orthocenter then is at the point negative 2, 1, 2, 3, 4. That's a little harder, isn't it? You want me to do that one more time so you guys can see how I got the slopes? Okay, one more time. So I think the one to look at is JK. We're looking at JK. The slope of JK is up 2 over 1, up 2 over 1, right? Up 2 over 1. That means the slope coming across has to have the opposite slope. Instead of up 2 over 1, it is down 1 over 2, down 1 over 2. So if you walk it, instead of down 1 over 2 or up 1, back 2, see it still has the opposite, down 1 over 2, down 1 over 2. We get the intersection right there, okay? So to be perpendicular, they have to have opposite slopes, all right? Okay, so today, and we don't have a lot of homework, that's probably not a bad thing.